Imagine walking through a normal day, the world calm, the ground steady, when suddenly the earth beneath your feet begins to roar. The street trembles, buildings sway like fragile toys, alarms shriek, and within seconds, what felt safe becomes terrifying chaos. This unstoppable force is an earthquake, one of nature's most unpredictable and destructive powers. It can level cities, reshape landscapes, and remind us that despite our technology and progress, we remain vulnerable to the raw energy of the planet. But what really causes the ground to move with such violence? Why do earthquakes happen, and what secrets lie beneath the surface of our seemingly stable world? The truth begins deep within the earth. Our planet may look solid, but it is alive with motion. The outer shell of the earth, called the lithosphere, is broken into massive puzzle pieces known as tectonic plates. These plates float on the asthenosphere, a semi-molten layer beneath them, and though they move slowly, only centimeters per year, their collisions and interactions store up enormous amounts of energy. When this pressure finally releases, the ground shakes, and we experience an earthquake. There are several ways tectonic plates move, and each movement can produce earthquakes. When two plates collide, we call it a convergent boundary. In some cases, one plate dives beneath another in a process called subduction. These zones produce some of the most powerful earthquakes in history, as seen along the Pacific Ring of Fire. At divergent boundaries, plates move apart, stretching and cracking the crust. Though these quakes are usually less intense, they remind us of the restless power beneath. Transform boundaries are another major source, where plates slide past each other. California's San Andreas Fault is a famous example, where stress builds as the Pacific and North American plates grind against one another until they suddenly slip, releasing energy in the form of seismic waves. But tectonic movement isn't the only cause. Volcanic activity can trigger earthquakes as magma forces its way upward, breaking rock as it rises. Human actions have also created artificial quakes. Mining, drilling, fracking, and even the filling of massive dams can disturb the balance of underground rock layers, releasing tremors. These may be smaller, but they prove that the Earth's system is sensitive to even the changes humans create. When an earthquake occurs, energy is released in waves that ripple through the ground. The underground point where it begins is called the focus, and the point directly above it on the surface is the epicenter. The first type of wave is the primary wave, or P wave, which moves quickly in a push and pull motion. Secondary waves or S waves follow, moving side to side and often causing more noticeable shaking. The most destructive, however, are surface waves, which travel along the crust, moving slowly but delivering devastating force to buildings and infrastructure. For thousands of years, people have tried to understand and measure these mysterious quakes. Ancient Chinese inventor Zhang Heng built the first seismoscope almost 2,000 years ago, able to detect the direction of a quake. Today, advanced seismographs record vibrations with great accuracy, allowing scientists to measure the magnitude of earthquakes. The Richter scale, once the most widely used, has largely been replaced by the moment magnitude scale, which more accurately calculates the energy released. What many don't realize is that each step up on these scales represents an exponential increase. A magnitude 6 earthquake is not slightly stronger than a 5, it releases 32 times more energy. That difference can mean the line between moderate damage and catastrophic destruction. But the question people ask most is whether earthquakes can be predicted. The short answer is no, not with accuracy. Scientists can identify zones that are more likely to experience quakes, like the Pacific Ring of Fire, but the exact time and day remain unpredictable. The Earth does not give reliable signals before it shakes. Instead of prediction, research focuses on preparedness. Early warning systems in some countries can detect seismic waves and alert people seconds before the shaking begins, giving them just enough time to duck, cover, or stop critical systems like trains. More importantly, earthquake-resistant buildings, strict safety codes, and community drills have proven to save countless lives. History offers chilling examples of the destruction earthquakes can unleash. In 2004, an enormous undersea quake off the coast of Sumatra caused a tsunami that killed more than 230,000 people across multiple countries. In 2010, Haiti suffered a magnitude 7 quake that flattened Port-au-Prince, killing over 160,000 and displacing millions. In 2011, Japan experienced the devastating Tohoku earthquake, followed by a tsunami that caused the Fukushima nuclear disaster. These events prove that earthquakes are not only natural phenomena, they are human catastrophes that leave deep scars on societies and economies. The damage from earthquakes is not limited to shaking buildings. They can trigger landslides, avalanches, and tsunamis. They can destroy bridges, cut water and power supplies, and paralyze entire cities. Recovery takes years, and the emotional trauma lasts even longer. Survivors often live with fear, especially as aftershocks, smaller quakes that follow the main one, can continue for weeks or months. Though weaker, aftershocks often cause severe damage to already weakened structures, making them dangerous and deeply unsettling. Earthquakes also inspire myths, legends, and cultural explanations. Before science provided answers, ancient people imagined supernatural causes. In Japanese folklore, a giant catfish named Namazu was blamed for the earth's shaking. In Norse myths, the struggles of the god Loki were believed to shake the ground. These stories reveal humanity's attempt to make sense of something sudden and terrifying. Today, science replaces myth with knowledge, but earthquakes still hold a sense of mystery and awe. In modern times, technology has helped reduce the impact of earthquakes. Countries like Japan, Chile, and New Zealand enforce strict building codes to withstand strong shaking. Skyscrapers in Tokyo are designed to sway instead of collapse, and early warning systems give residents a few seconds to prepare. On an individual level, simple steps such as securing heavy furniture, identifying safe spots in homes, and practicing earthquake drills can save lives. Preparation is humanity's strongest defense, because stopping earthquakes is impossible. Despite the fear they cause, earthquakes also tell a story of creation. The same forces that bring destruction also build mountains, carve valleys, and shape coastlines. The Himalayas, for instance, exist because of the collision between the Indian and Eurasian plates, a process that continues to this day. Every landscape we see carries the marks of tectonic shifts and earthquakes over millions of years. Without these movements, the world would be flat and lifeless. So while earthquakes frighten us, they are also the very reason our planet is as beautiful and diverse as it is. They remind us of our fragility, but also of the grandeur of living on a planet in constant motion. Earthquakes show that the ground beneath us is not dead rock, but part of a system alive with energy. The forces that scare us are the same ones that have sculpted the Earth's beauty. They are not punishment or mystery, but natural processes of a restless planet. So why do earthquakes happen? They occur because our world is always moving. Tectonic plates shift, stress builds, and eventually the pressure must be released. Sometimes it comes gently, unnoticed. Other times it comes violently, shaking cities to their foundations. The challenge for humanity is not to stop earthquakes, for that is impossible, but to live wisely on a planet that will never stand still. The earth will always shake, and our task is to respect that power, prepare for it, and remember that the very ground we walk on is alive with the forces that shape both destruction and creation.